Wheels are an essential to modern mountain biking, and good wheels can make your bike great. But what goes into making a better mountain bike wheel? Thanks to FSA, we're here at their Taiwanese factory to find out how they make World Championship winning mountain bike wheels. FSA have been in business making quality bike parts since 1993, and this is their new state-of-the-art factory. Let's go and see how high-end products are made. Designing a product is one thing, and that's part of the process. You've got to imagine, you've got to get creative about producing a new product. But producing is the key thing, and that's where FSA and this massive room of engineers does something that not a lot of other businesses do, and that's really dig down in both the engineering of the actual product but also the production engineering. They've got software to allow them to study the flow of materials, the strength of carbon fibre layups, using CAD and CAM systems to help them develop the products on the computer and in the test lab. It means that they can produce consistent products time and time again. But just to reiterate, we've got a whole room here full of engineers. I've not seen that in the bike industry at all. We're here at FSA's carbon facility. This is where they make all their carbon products. It's their own factory, and this is the first port of call for a carbon rim. So, carbon fibre, a little brief about it. Think of it more like fabric, because that's what we've got. We've got a fabric here, and okay, we're going to make it into some amazing structure, but we've got to think of sort of like back to basics about structure and about science. Think actually about a cotton t-shirt and how a cotton t-shirt is essentially cotton, but then we've got jeans, both the same base material, but how they're woven together and the actual weight of the material changes hugely. Now, the other factor, because we're talking about composite, we're not riding just soft fabric carbon bikes, we're also talking about resin, which on average takes up about 1/3 of the weight of any carbon fibre part, but it eludes and exudes lots of different properties. And what those properties are, they're going to be really specific. FSA work really closely with their partners to get the exact engineering requirements that they need. But how do they check that? In a lab, just like this. How do you ensure that the carbon fibre and the resin and the prepreg are to that exact engineering property? Well, you'll take a sample, just like this one, and then you're going to test it. And we've got various devices of incredible precision to check what's going on inside this carbon fibre prepreg before we even make, well, any wheel or any mould. So this first one is going to heat up and then weigh the resin and then the carbon fibre. We've then got a machine that actually checks that the curing cycle is to the exact design and structure that you need. So it's going to cure and form the resin composite structure at the right time. This machine is designed to, well, check the resin and not just kind of look at it, but do spectral analysis. What do we mean? It's going to fire an infrared light into the resin, and they're able to check that, well, all this little amazing graph here picks up as it should do. So each of these apparently links to a different chemical bond. So the chemical bonds that they need and require are going to be very specific for the specific resin. It is really cold in here, and there's a logic for it being really cold. That's because all the prepreg is stored in here. So that's the carbon fibre with the resin already semi-infused. Not completely all the way through, but if it was at room temperature or warmer, well, it'll get sticky and tacky. So it's kept in this industrial freezer to keep it just right. After we step out of the freezer, we roll out that rolled up section of prepreg. We lay it flat, and then we start cutting it, essentially. Think a little bit like wrapping a gift. You've got to make sure that you've cut sections in the right order, otherwise it just turns into a bit of a crumply, awkward shape. And with a composite, we need it to be really uniform and really smooth to allow that prepreg, that resin, to flow into the part and make it one piece. So that whole process starts with amazing moulds like this, where they're going to cut sections of the carbon fibre up. This one is actually an older one because it's a physical press where it would have been stamped and cut in. So this edge is exceedingly sharp. I think I'd lose a toe or a whole foot if I dropped it. But the modern machines here use multiple access beds that cut the carbon fibre into very intricate forms. This machine isn't in use, but it's key in telling the story about carbon fibre. This is a unidirectional roll, so all the little fabric, all the sections of carbon fibre, all in one order. They're all pulling through in one direction. And that's really important because as you play with the weight and the ply of these materials, in terms of the layup and how they cross over, it can change the structural properties of carbon fibre. And that's why the other machines are doing lots more here, because FSA are already playing with how their materials can work from the very first cut. So there's sections of material that we were on that first machine where all the orientation of those fibres are all in the same direction. That gives a strength that's quite unique in just certain directions. And that's where FSA really spend the time to just build in the quality, because they're doing their own orientation, their own laying up and different layup of these fibres. And that's what they're doing just here. They've got sections that are pre-cut and they're actually changing the orientation to ensure that it is exactly what they want. So after we've created the first sort of layers, the first ply orientations where we're changing the direction of the unidirectional fibre into multi in different angles, 45, 60s, there's a lot of secrecy there. It then comes to another cutting machine where it can make really precision cuts of really complex parts. And the complexity isn't just that, well, you're cutting something out that's really fiddly. If you're having to cut it with a scalpel and a straight edge, you would be here for hours. That isn't the complexity. No, it's the engineering know-how that takes something that is essentially flat and turns it into something 3D. Here's an example of the cutting that I was talking about. Whilst it looks like a, well, interesting form and shape, this is actually a net to create a really complex 3D shape. Think of it, again, back in school, you might have made small paper cubes and you had to kind of cut them at precise angles to make sure that when it was folded up, well, it all fitted together. Well, think about doing that, but then think about that in a 3D form. It's what we're starting to see here. It is really smart stuff. Okay, the first step of making a wheel, well, we've seen probably the first step, but actually hands-on carbon wrapping stuff is a inner rim section. We're not allowed to show you a lot, but it's very, very clever and actually really innovative. And it means that FSA can ensure that the rim bed and sort of core of the wheel is built to a very exacting standard. Okay, behind me, there's a lot of carbon manufacture happening. So we've got those individual layers, those ply of material that we saw from upstairs. And I think this is where it's really fascinating about the construction of carbon fibre. There's some parts that look just a bit like a tube. So with metal, you could extrude it and you could do different wall thicknesses and you could change where that wall thickness was to get different properties. But, well, essentially, that's about it. Maybe you could machine it afterwards as well. But here with carbon fibre, we're able to actually change and reinforce particular areas of that tube to make it work in very different ways. So these might be seat posts being made behind me. So at a specific point along the seat post structure, they've got more layers of carbon. They're going to be reinforced. And that means that not only the part can be stronger in a key place, maybe around where the clamp might be, but it also means they can change the properties of how that post functions. So you could make a more comfortable seat post. It's all action behind, lots of rims being laid up. You can literally see them being laid up as we speak. Each of the layups will come in this kind of like scheduled little box and bundle, and then after a minimum of 2 weeks training, well, that's when the layup process can begin. And there's lots of clever details in this mould. You've got sections that slide out of the way and then clip into place. They have to endure huge amounts of pressure, around sort of 5 to 10 tons, squidging them, and then the bladder that's inside the mould will be up to 12 bar of pressure. And you might wonder why they're kind of wiggly shapes and why they're little inserts. Well, the bladder has to be inflated, so there has to be air into the mould, and then those wiggly shapes, well, that's the spoke reinforcement holes. This one is a road rim, so it's a little bit deeper, but those same rim reinforcements will be on the mountain bike rims as well. the smarter viewer out there, so that's pretty much all GMBN will notice that this is only half a wheel. Well, actually, it's only a third. So simultaneously, we've got one side being constructed, we've got another side also being laid up. And then there's these inner assemblies which have already been pre-assembled, which will get inserted later down the line. As you'll have seen from some of the manufacture, some sections are moulded directly into the mould, so that layup happens there. But some parts, like the part behind me, is getting effectively like pre-assembled, a bit like a sub-assembly. So what's happening with this one is we're getting spoke hole reinforcements. So that's a small pre-pregged little tab of carbon that helps strengthen that part of the wheel. We're also getting the holes themselves knitted in. So she's using a tool that slides through the layers. It's heated up a little bit because the resin at this temperature is still quite hard. So it wiggles in and opens up the weave itself. Then we're getting a small plastic bung. This is to help actually mould the spoke hole. So the structure is moulded from the off. It's not drilled, it's not compromising the structure. When it's all moulded as one, it's going to be strong. So what's happening behind me? We've got the drive side and non-drive side halves of the wheel coming together, and they're going to get stuck together in this machine here. Well, that's the two sides of the mould. So it's bolted together, and then there's a bladder with this specific rim, often the case with lots of hollow form carbon structures. It's pressure tested, so a bit like when you fit an inner tube into a tyre, before you put the other bead on, you inflate it just a little bit. That's what's happening here. Then it's off to get heated, moulded and cured. Here in these pressurised ovens, the real alchemy. No, the real material science happens. The curing and cooling processes are again highly precision processes that are tightly controlled. The careful balancing and interplay between the heat, pressure, flow rates and resin curing all work their magic to ensure that the fabric form turns into a near finely finished part. With batch production, sometimes you're in phase with production, sometimes out. We're out of phase with this drilling machine. This comes after all the finishing of the rim, so it's almost a complete rim and it's ready to go. Well, need some holes for the spokes. And those spokes holes need to be drilled in a really specific way. We've got the moulded plug, which helps guide the process and creates a gap in the carbon. But we still need to drill a hole in the spoke bed so that we can adjust the spoke tension and build the wheel. And that's what this machine does here. It is a computer numerically controlled drilling machine, and it is really clever. It uses the valve hole as a datum, and then the drill is further in there, and that actually moves. It's angled, which is very clever. It's not just a straight hole, and that's partly because FSA can design the whole wheel as a system. You're not just designing a rim by itself and a hub by itself. It's all designed to work together, including the angle of the spoke holes. So the rims themselves are almost complete. At every stage, we've seen quality assurance. We've seen how they've got safeguards to make sure, whether it be weighing the materials, checking that the layups are all in the right box. But there's one last bit of checking. That's this highly advanced machine here to make sure that the parameters and the quality control is still there. Okay, that's all things carbon wrapped up. Now it's time to head back to the main facility to, produce some wheels. Okay, that's the carbon facility where the rims are made. Let's see how the rest of the wheel is made. So we've got to look at how the hubs are machined and how that whole wheel is brought together, how it's laced together into a complete wheel. Let's go and see. Here is a free hub body, and it looks kind of like a normal XD free hub body, but when you look a little bit closer, there's a lot going on. And a lot going on means that there's a lot of machining. Now, the quality control and the kind of quality assurance here at FSA on all their products is really high. So high that I had to invest in a new machine, a skiving machine, a power skiving machine. It's clever. Essentially, you've got a machined part that's machined on, well, this end and that end. Now, you have to think a little bit about machining to kind of get to grips with what's going on. You put a normal item in a lathe, you can work one side, but there's a part that's clamped. Same with if you're kind of using a milling machine. The machine behind me is able to do high precision machining. So there's a lathe on there to do sort of normal cutting, but there's also a mobile cutting head as well. And this is where it gets really clever. Once it's cut one side, the machine is able to move the part across to a second sort of gripping area, and there's more lathing, more machining to be done. At the moment, it can do 3 parts all in one go. And the real clever stuff is that transition from one machining head to another platform. Because the datum, the 0 point, essentially stays the same. Whereas if we were manually moving it or doing anything else, you'd lose that precision. And that's what these parts are all about, is ultra high precision. Another advanced bit of machinery here, doing lots of, well, multi-axis machining or skiving. But this interesting little puck, it's simple, go or no-go gauge. So just a great way to check the machining is hyper accurate. It just fits on, he says, and you can check if it fits or if it doesn't. There's loads of these little checkpoints along this factory, and that's the best way to flag this high precision work all the way through. The majority of the machining down here is aluminium, and aluminium is highly recyclable. And FSA, well, they do their bit. They recycle a lot of the swarf from the machines. They collect it all, use these machines to actually bundle it up into these pucks of aluminium. And yeah, they then sell it back to their supplier, which gets recycled and made into, well, more aluminium billet. Okay, that's the hub all machined. It needs to get shot peened or sandblasted, and then it needs to get anodized. That's a process that happens outside of the factory walls here, so they'll get shipped out and then come back. Once they're back and they're black and they look amazing, well, then it's time for hub assembly. Let's go. Okay, this is almost a finished hub. It's not quite. Last time we saw it, well, it was a different color. It's been sandblasted and it's been anodized. That anodizing creates this wonderful deep black surface. It also protects it from corrosion. But now we've got to do some laser etching. We're going to put a QR code, which means that you'll be able to find out all the service details of your hub just from the QR code. We've shown how to machine a hub, then we've got anodizing and we've got decal application, but there's a lot more to making a hub into, well, a functional part of your wheel. We've got to do some assembly, and it all starts here. The first stage behind me is rollering. This is where a roller device is inserted into the free hub driver and, well, just smooths it out. So it makes the next stages of assembly even better. And that's just to make sure that the roundness is hyper accurate. So when we press in the bearings and the sub-assembly and more bearings, it's a really simple process. And as we've seen at each step in the production line, there's more QC as we go along. So there's a torque device which measures how much rotational force is needed to just start turning the hub. And it's a simple yes, no. If it's got too much torque to rotate, it's not going to be used. QC runs all the way through FSA. Now we've got all the parts of the wheel ready to assemble. And that's what we're going to do next. And, well, we've seen robots, we've seen incredible machines. Now we've got probably the best machine in this whole factory right here. This is the first process, is lacing the wheels up. And this is done by hand. Next, we're going to go in and see all the next steps to create, well, from that vaguely sort of wheel-looking object to something that is a functional, ride-ready machine. Wheels have been made, they've been kind of brought up to true, they've been then trued, then they're kind of tensioned and detensioned. They've got dedicated machines. Now there's more QC, there's more dedicated checking of what's happening. So what you can see behind me is spoke tension being checked with a gauge. The gauges are checked every day and recalibrated every day, so their accuracy is bang on. But what's really fascinating is all of those spoke tension details are listed. So when FSA send a wheel out, they know who made the rim. They did. They know who made the hub. They did. And they know which batch of rim and hub it's made. And the key bit of pulling this whole wheel system together, the build. They know who built it. They know what spoke tension it was when they left the factory. Testing, it's an inherent part of mountain biking. But what's unique here at FSA is that Well, they've got their own test lab. They do testing from every batch, and it is brutal testing. It's above and beyond what ISO do, and it means that, well, it all feeds back into the development. They can make a better product when they know what part fails or when it can fail. They can reinforce against something. Having your own test lab, just like this one that FSA's got, means that you can do, well, yeah, a lot of testing. And that means you can dig down into what makes a stronger wheel. And I guess one of the myths that's around with carbon wheels is that they're for racers only and they're not very strong. The test rig behind me, well, disproves that completely by testing to the UCI limit and then actually double its limit. At the beginning of the video, I talked about how a great wheel can change your ride. And okay, defining a great wheel can be tricky because, well, there's so many different segments. But defining a great wheel from a production perspective, well, I think FSA might have cracked the code. Their quality assurance and quality control all the way through the stages of a wheel in production is, well, second to none. From checking the material of the carbon fibre is exactly what they need, doing spoke tension checks, but also checking the spoke tension machine is actually correct. And then, of course, there's all that quality control in the machining, which is lots of it in-house and lots of it to a really, really high standard. It's very impressive. Well, I've been impressed, but have you been inspired by this video? If you have, well, join me in the comments down below. And if you haven't already, do subscribe to the channel because it helps us make videos just like this.